Hi, this is video number 17 for things not working, and it is called variable flow function in iRIC. Okay, the variable flow function in iRIC is taken from the very same function in MATLAB. And the way it works in MATLAB is that you run the MATLAB model once with the variable flow function enabled for the years that will be modeled. You run that in the calibration mode. Let me show you how the feature works in MATLAB, and I'll be using the data that Frank sent as the test data for this function in his iRIC example. Here we have the MATLAB program. When I get around to running it, this is one of a past run. When I get around to running it, you won't see the run screen appear on this. I have two monitors for my computer. The left-hand one does not appear in the video. But I'll bring things in when they're important. Okay, as I said before, we've set to run from 2004, which is the beginning time, and we run this where it says automated calibration. We press manual. We input our variable hydrograph. Okay. This is the flow data that Frank sent in his test case. And now MATLAB is running on the other screen. The run is complete. That is essentially a calibration run. And let me show you the files that it has created that are critical. Here we go. Within the MATLAB program, it has created this file that's called annual power calib.dat. It looks like this. And that's the annual power for this particular run. It also creates another file, a very similar kind of file, but this is the scaled annual power. Again, for the same run. And in this case, it's the power scaled. Now that we've done that particular phase, which can be called a calibration, we're now going to run a scenario. We'd like to start from channel 1, which is 2004. We do want to run it for the full time period to 2086. We're going to call this video test. And we do want to input variable hydrograph. So called, and there it is. Okay. Now the run is occurring. Again, it's occurring on the other screen, and I'll pause so you don't have to wait. Now our MATLAB run is finished. I want to show you the results of that run. It's my GIS program, and I've already loaded the files in. There's the migration with the variable flow. What I like to do to look at it a little more detail is I like to zoom in on one particular area, an area that shows us the nature of the variability of the migration. Now, I have done a run earlier where the variable flow was not utilized. It was just uniform flow. I just want to show you a comparison with that particular run. Turn this off. There's the same area with a uniform flow. You can see uniform spacing. There it is with variable flow. So in MATLAB, first you run the calibration function in order to create stream power files. Then you're ready to do your actual modeling, in which you forecast or predict the migration based on variable flow. iRIC has a variable flow dialog box that was created for iRIC. I never actually got to be instructed on how this dialog box is supposed to work, so I have made my best guess on how to use it. In hindsight, it would have been best if someone had made a video that had instructed me on its use. But, on the other hand, it's also valuable to see how intuitive using this function is, and if I could just simply figure out how to use it from what I see. So this is a report of what I found out when I tried to use it myself. First I will open the program and show you the particular dialog box I'm talking about. In the calculation condition settings, it's the flow. So here we choose variable discharge as our flow type, and we have to have these flow thresholds, which are the same that are used in MATLAB. And what I found is that there are two input files. One is the flow data, and as I found it, it was these data here. I'll call it ESO data that Frank used to use as the test case. So that's the ESO data that goes in. And then there's another one here that says annual power calibration dat file. And that is the annual power calibration that Frank had. Okay. Let me state the final conclusion of this video right up front before we go any further, because things get a bit confusing as we move on. The final conclusion is that this variable flow dialog box that you see on the screen needs to work off of the flow data alone and not have the power needed to be input. I'll say this again later, but we need to work off the flow data and nothing else. I will go on and talk about extra details that are confusing, but maybe they would be cleared up when this dialog box uses the flow data alone and not the power data. Okay? Now there's one more piece of data that's important, and that was the erosion grid. And this is the erosion grid that Frank had chosen and sent. So we save and close. So as you know, there's nowhere to compare this with MATLAB at this time because the basic runs don't agree. Nonetheless, I'll move on to look at this function as it exists in iRIC. Okay. First of all, I used the exact data that Frank sent me, and I ran it in iRIC, and I got different results. To repeat that, I took the identical input files that he specified, and I ran the program in iRIC, and then I took the output data that he sent, and I compared the two, and they differ. Okay? I'll show you that difference. These were close in on a few lines of Frank's original output, and here's the output I get. You can see they don't fall on top of Frank's lines. Differing data. I don't know why, but it makes comparisons going down the line of other things pretty difficult when I can't even match his output data using the same input in iRIC. Okay? So I'm just going to give you a verbal summary of what I did. I assume that the program runs off the power file. That would be the appropriate assumption. My later experiments question that, or it makes me question that. At least it depends on the power file in some way, or it wouldn't have been included, it appears to me. So there are three possible things that there are three ways that the output can be created. It can be created from the annual power file alone, or it can be created from the flow data alone, or it can be created from some combination of the two, which would be quite confusing to me. And I ran tests on each of these possibilities by, first of all, holding the flow data constant and varying the annual power file. And then I held the annual power file constant, and I varied the flow fields. And in both of those cases, I got different results. So, although it appears one has to enter both the flow data and the power data, it's very unclear what the output depends on. And it looks like it depends on some combination of the two, which is really very confusing. All of this may be resolved if the code in the dialog box works on the flow data alone. That way there's no ambiguity. It's just the flow data. And if power needs to be calculated, it would be calculated internally in the program, just as it is in MATLAB. Okay. I said there's a lot of confusing things going on here, so I'm going to call them sidebars. Sidebar number 1. Let me show you the annual power file that Frank used with those flow data. Okay? Because I think the annual power file that he used for the flow data was not matched to the flow data. I made an annual power file from the flow data, and I compared it to the one that Frank used, and I see that they differ. So let me show you that a little bit here. So here's the file that Frank used as the annual power in running that program. And here's the annual power I made using the flow data that we had. And although the decimal points differ, you can see this is 2,000, that's 3,900, 3,900. This is 79,000, this is still 39. In 2007, 0 here, and it's that. In other words, these files differ. What I note is that the power file that Frank used for his test case was actually an old one that I had made in 2007. And I don't recognize those flow, this ESO flow. That looks like a flow data set that I've never seen before. So it would have been very hard for me to have made a power file related to a flow that I'd never seen before. So I think he's using the wrong power file with the wrong flow. As I said, that's a sidebar. That's not particularly important. It just seems to be some error, and it may explain why my results didn't match his results. Okay, sidebar number 2 here. Let me put it up for you. I really wanted to test the power file and see how it operated, if it was what really controlled things. And so what I did, let me get this here. I made a power file, and I guess I can show it to you. Made a power file that consisted of 20 years of data that had 0 power. Okay, let me show you that power file. So I just created a synthetic power file. From 2005 until 2030, there was 0 power. And then there was 30,000. And then there was 420. So the hypothesis is it would show no migration because there was no power. Okay? Now let me show you the data there. The lines are very faint, but you can see them. It shows migration when the power file has 0. Again, this is a small sidebar. It's not the main issue. Okay. This was a very confusing test case, although there's a simple answer, I believe. With my experiments, it's really unclear that in the current condition, what really controls the migration pattern with this variable flow dialog box. Is it the annual power file? Is it the raw flow data file? Is it some combination of the two? And I found that changing both the annual power file and the basic flow data made some difference in the results, and that the results were hard to interpret. Again, it's a little bit beside the point, because the main point is that there needs to be only one input in the program calculation conditions for variable flow, like there is in MATLAB, and that needs to be the flow data alone. If the annual power is needed, like it is in MATLAB, it should be calculated internally by the program, like it is in MATLAB. Okay. Thank you.